The signs are different, so you subtract. 12 minus 8 is 4. The higher one is a negative, so it's negative 4. Now, number 2 asks that you add 5 black chips. So we add 5, black is positive, so we add a positive 5. So, because it's all addition, it's order of operations, I take the first 2 first, and then with that sum, add the positive 5 chips. So, we already know that this was a negative 4, because we solved it in the original. So, what's negative 4 plus a positive 5? The signs are different, so you subtract. 5 minus 4 is 1. The higher number is a positive, so it's positive 1. Now again, we already know that this original board is equal to a negative 4. Number 3 says to remove 5 red chips. If we follow the rules, it's keep, change, change. Now, it's the same as it was here, is it not? That this problem, after we change it, is exactly like the problem we just solved here. So it's a positive 1.
I did.
Now, we already again know that the original board is a negative 4. Number 4 wants us to remove 3 black chips. So if I keep, change, change, keep, change, change, now the signs are the same. What do I do? Add. 4 plus 3 is 7. They're negative, so it's negative 7. We already know for 5 the original board is a negative 4. So it now tells us to add 3 red chips. Add 3 red chips. Is this not the very same as this one? So we already know that the answer is going to be a negative 7. The signs are the same, so you add 4 plus 3 is 7. They were the same negative, so it's negative 7. For number 6, number 6 didn't ask us anything about the actual problem. That means I don't have to go back to that original board. It says, what patterns do you see? So, each time we had to remove a negative, we actually were adding the opposite, and it gave us the exact same thing as it did for the one above it. So, what they want you to see in asking you, are you seeing those patterns, is if I had something like 4 plus negative 3 is the same as 4 minus a positive 3, that these two are the same thing. Because when we had to change it, we ended up with the same thing. When we had to change it, we ended up with the same thing. So they're wanting you to see that by adding the opposites, these are really the same problem. So those were the patterns that they wanted you to see for these two being the same answer. When we done the keep, change, change, we ended up having the same problem. And these two were the same answer. When we did keep, change, change, those two ended up being the same problem. So that's what number 6 was asking us. Do you see those patterns that happened as you went through the process of doing A? Any questions about A? Starting B. B, you have to use that original board that's on page 18. It says to start with the original chipboard from question A and then describe 3 ways to get a total value of -2. So what it's asking for B is that I know that I have a positive 8 plus a -12 in my original board. And I know that that answer is a -4. Yes. It wants you now to get an answer of -2. So how can I make that happen? Yes. I could add something to either one of these that would cause this to come down to a -2. So if I know I have -4, I would add +2 chips to actually bring it down to a -2. So that means I need 2 more positive chips. So this would really be a +10 plus a -12 could equal a -2. And I found that out by using the original board, knowing what I would end up with in the original board, and knowing now what they want my answer to be. Yes, quickly. Now, for time's sake, we're not going to do 3 ways for every one, because our goal is to get down to E6 in this problem. So we're only going to do 1 way right now to get to where they're asking us to go. And then if we have time, once we get to E6, we'll come back to B and C and do those other ways. So for number 2, it wants you to use that original board, and you know that we end up with -4. But for number 2, our answer needs to be at 0. So if I have a -4, what do I have to add to -4 to get 0? Four positives, because you have to make 4 sets of 0 pairs. That's how they're going to cancel each other out and be 0. So now I have to have +4 more to get to 0. So 8 plus 4 is 12. So a +12 plus a -12 would be 0. So for number 1, I would have to add 2 more positive chips to the original board to get an answer of -2. For number 2, I would have to add 4 more positive chips to the board to get an answer of 0. Number 3 wants our answer to be -4. So what can I do to this board that's going to give me an answer of -4? If I already have a -4, we're not going to add anything. We're not going to remove anything from this original board. It's going to be A plus -12. You know, in A, it was asking us to add something or remove something. This one was found out to get the desired answer, we had to add 2 black chips. To get the desired answer, we had to add 4 black chips. So to get the desired answer here, we don't have to add or remove anything. It already is the answer we need. Yes. Quickly. We're now down at C. Now, C isn't tying us to using that original board in A. it tells us to give 3 combinations of red and black chips. You have to use both red and black chips to get the answer that's here in C. So I'm going to do one for you, and then I want you to give me another one on your paper. So if we're looking at C1, they want the answer to be 0. The only way you're getting at 0 is to add 0 pairs. So my example for C1 is going to be a +3 plus a -3. Now you give me one under yours. Yes. When Jada gets back. Number 2, they want the answer to be a +12. Now remember, you have to use negatives and positives to get the answer they want. So my example, I'm going to have a +24 add a -12. Now you give me one that's going to give an answer of +12. And don't use mine. Number 3, the desired answer is a -7. I might use a -17 plus a +10. Now you give me one that's going to equal a -7. And then number 4 wants the answer to be -125. If I had a -130 and I added a +5, that was going to leave me with a -125. Now you come up with one that's going to be an answer of -125. Now C asks for 3 examples for each one, but to save us time, I'm doing one and you're doing one. And then if we have time when we get to E6, we'll come back to B and C and then do the rest of those examples. Any questions about C? Yes. 2 minutes. We're in D. Those of you who've packed up, break is over. You will turn A through E in when you leave. I would not think it would be smart to pack up 10 minutes early. We're working till the bell rings. D wants you to find the missing part for each chip problem. Now, this is a different way to look at it because they've given it to you in a table. They said that we're going to start with 3 negative chips. We have to add 5 positive chips. And what is that going to end with?
+2.
+2. There's 3 0 pairs. +2 is what we end with. They want that number sentence. So that number sentence is -3 plus a +5 equals a +2. Now, if you have to go back tonight and go on the plan book, these worksheets, these pages from the book are online in the plan book. You can go back and go through the whole lesson again if you need to. Number 2 says I've got 2 negatives and a positive. They want me to subtract 3 negatives out. Well, I don't have enough to subtract 3 negatives out. So I have to put in a 0 pair, so I have enough to take out 3 negatives. And what's left? 2 positives. So my number sentence for number 2 is I'm going to have -1, because when you take that 0 pair out, you've got a -1, subtract -3 is equal to a +2. And when you do that keep, change, that shows you how you ended up with a +2. Number 3 says I have 6 negatives. What do I have to do to end up with 2 negatives? I have to subtract 1, 2, 3, 4 negatives to end up with 2 negatives. So this is going to be -6 subtract -4 is equal to -2. Because when I keep, change, keep, change, I have -2 left when I subtract. Number 4, what do I have to start with if I'm going to subtract 3 negative shifts and end up with a +4? That means I had to have already had 4 positives. If I'm subtracting out 3 negatives and I end up with +4, then I would have had to have had this to start with. Because if I'm going to subtract out 3 positives, these are 0 pairs. So I would have had to have had 1, 2, 3, 4, 5, 6, 7. Then subtract out a -3. Because when you keep, subtract out a +3, because whenever you keep, change, this has to end up in the +4. So I'd have to have, it's the same as adding +3 and ending up with +4. So I'd have to have that 1 to begin with. And then add the 0 pairs to be able to take away the 3 to end up with the 1, because those 3 0 pairs would come out. And then E is the same as what you were doing in D, but it doesn't have a chip table. It just gives you the problem and it wants you to solve them. So this is our last step. Tomorrow you have a checkup for investigation 1, because this 4th one finishes the whole investigation. So for D, nope, this is E, sorry. You have positive 3 subtract positive 2. Negative 4 subtract positive 2. Negative 4 subtract negative 2. Positive 7 plus what gives you a positive 1. Negative 3 subtract positive 5. And then what minus a negative 2 gives you a positive 2. So this one is keep, change, change. They're different, so I subtract. 3 minus 2 is 1. The higher one is positive, so it's a positive 1. I could do this with chips, but when these numbers get to be bigger, fractions or decimals, you're going to want to stick to those rules. So keep, change, change. They're now the same, so you add. 4 plus 2 is 6. They're the same negative, so it's negative 6. Another subtraction, keep, change, change. They become different, so I subtract. 4 minus 2 is 2. The higher one is negative, so it's negative 2. If I have 7 and I want positive 1 left, then I have to subtract out 6 0 pairs. So then I'm going to leave that positive 6, negative 6 would cancel out, and it would leave me positive 1 over there. This one is keep, change, change. They're the same, so I add. 5 plus 3 is 8. They're the same negative, negative 8. And if I keep, change, change this one, change, change, what do I have to add 2 to get a positive 6? Positive 4.
Are you going to finish papers?
You are. We did not do letter F. If you would like to go on the plan book tonight and pull that page back up and have access to it at home and actually go through F on your own, that'll be fine. I need for you to make sure that you have your name on your paper and that you go turn it in the basket before you leave.